Hi, Professor Bob Young back at you here. And in the upcoming videos, we're going to look at what's called rational functions, which are really fractional type functions. So we're going to start looking at what's called the reciprocal function, f of x equals 1 over x, and another one, f of x equals 1 over x squared. So rational functions, or fractional functions, as I said before, are in the form f of x equals p of x over q of x, where p of x and q of x are polynomials, with q of x, of course, not being equal to 0, or the fraction would be undefined. And here are some examples of some rational functions. Y, or f of x, equals 1 over x, which we're going to get to in a minute. Y equals x plus 1 over 2x squared plus 5x minus 3. So you've got the old p of x and q of x there. And f of x equals 3x squared minus 3x minus 6 over x squared plus 8x plus 16. So, they may call this one over here p of x in this form divided by, they'll call this one q of x. So they're just polynomials. Now notice it says since any values of x, such as q of x equals 0, are excluded from the domain of the rational function, this type of function often has a discontinuous graph. In other words, it's going to have some breaks in it when we go to graph these creatures down the line. So let's start with the easiest one here, the reciprocal function y equals 1 over x. And what I want to do is I took out the old graphing calculator and I put that in there, and then I looked at some table of values as x gets closer and closer and closer to 0 here. So you might find this kind of interesting here. So let's look at the top chart. And again, I'll put right next to this y equals 1 over x. And we'll come in from 0 from the negative side first. So notice when x is negative 1, well, y would be negative 1 as well, putting negative 1 in down here. Be 1 over negative 1. Notice when x is negative 1/10, this gets a little interesting now because we have 1 over negative 1/10. Now remember, when you divide fractions, you have to multiply by the reciprocal. So when x is negative 1/10, y would become negative 10. And check it out as x gets smaller and smaller, getting closer and closer to 0. Negative 1/1000th, x becomes negative 1000, and so forth. So in other words, as this gets closer and closer and closer to 0, let's say here, we'll put in this column, as x gets closer and closer to 0, y is getting smaller and smaller and smaller. It is getting closer to negative infinity. Now on the other side of the chart here, we're coming in from the positive side here. So notice as when x is 1, y is 1. When x is 1/10, y becomes 10. And 1/1000th, y becomes 1000. Now could you imagine here, this would be 1 times 10 to the negative 6 power. That would be 1/1,000,000th. Y down here would be the number 1 million. So again, as x gets closer to 0 from the positive side, y is jettisoning up toward gargantuan numbers, toward infinity. And that's what it's saying down here. As x gets closer to 0, the absolute value of y, or f of x, gets closer to one of the infinities and beyond Buzz Lightyear. So notice it says the symbol x with that line there, 0, it's just a way this line, and when you all get to higher level math, those of you that go here will know this symbol means approaches here. So it says the symbol x approaches 0 means that x approaches 0 without necessarily ever being equal to 0. Since x cannot equal 0, the graph of y equals 1 over x will never intersect the vertical line x equals 0. And this line now is going to have a special name. We're going to call it the vertical asymptote. All right, and Young likes to abbreviate this, the VA. On the other hand, as x gets larger and larger and values of y equals 1 over x gets closer and closer to 0 as shown in the tables, letting the absolute value of x get larger and larger without bound is written the absolute value of x approaches infinity, causes the graph to move closer and closer to the horizontal line. Now this line is called the horizontal asymptote, and I think some of you know what I'm going to abbreviate it. Looking up top there, the horizontal asymptote I'm going to call the ha. So we've got the va and the ha. The va. Stop it, Young. All right. Now let's look at this graph, our friend y equals 1 over x. Now notice they put some points in here. Let's start with some positive points here. So notice again, when x is 1/2, the reciprocal of 1 over 1/2, y would be 2, 1, 1. When you put 2 in for x here, you get 1/2. So they've got these points plotted here. And they've also got some negative values. Now what I like to do, I like to get like different colors here. And whenever I do a va, I'm going to put like a little dotted line down here. The graph will never cross or touch this line. It will never cross or touch it. All right, now the ha, we can also go ahead here. So when I graph these later on here, I like to get these in the crosshairs. I didn't say it couldn't cross or touch the ha. It can, and there's ways we can determine if it does or not, but we'll get to that either way. So notice it says as y equals 1 over x decreases on the intervals, negative infinity to 0 and 0 to infinity. So they're saying that this graph is always decreasing. So again, if you remember increasing, decreasing constants, we got some good review now. As we come in from x this way, it's decreasing. It starts having a negative slope. And even as it keeps going on the positive side here, as this keeps moving along x, this slope here decreases forever and ever. So this would maybe not be a good investment, this function. Notice it is discontinuous at x equals 0, this graph. Now, if you want to talk domain and range, the domain of this function is all x values not equal to 0, okay, because it'll never get to 0. It gets close to 0 here, gets close to 0 here on x, but never gets there. The range is also all numbers except for 0. Now notice the parentheses here means does not include 0 here. So again, as we get closer over here and over here to the x-axis, y gets closer to 0, but never gets there either. So that's that discontinuity thing we're looking at. All right, now notice the y-axis is the vertical asymptote, or va, as I like to say it. So we've talked about this already. While the x-axis in this case is the horizontal asymptote, or the ha. Now, this is an odd function, more good exam review here, because it is symmetric to the origin, if you remember that. So in order to be an odd function, you have origin symmetry, this y equals 1 over x graph. And now notice we can also do some stretching and translations with these graphs. Since they are functions, they behave like functions. Now notice if we graph y equals negative 2 over x, that we're going to stretch this thing. Remember when they're, and another way to write that, as it says down here, which is also a good thing here, would be we could take that negative 2 out in front, and then there's our function we graphed on the last slide there. Now remember, the negative 2 either makes it fatter or skinnier. Now in this case, it's going to make it skinnier, and the negative is going to flip it about the what? X-axis. So let's go back and look at the previous one. There it is. Okay, look at how it's behaving there. Look at this one. It flipped it about X, and it made it skinnier. Now notice the domain and range still is the same here. Still negative infinity to 0, 0 to infinity. So we got some cool things going on. Now, if we graph this function, y equals 2 over x plus 1 here, notice that we have some shifting going here. We could also write this like they put here, and this is a good thing to write, so we'll put this in red. 2, we can yank the 2 out of there and say that's times 1 over x plus 1. Now that x plus 1 down here, notice it's the old horizontal shift, the direction you don't expect. It goes 1 to the left. All right, now since that's a positive 2, it stretches it a little bit there. I mean, it makes it skinnier, this 2 right here, but not being negative, it doesn't go flipping it about x. So there's some interesting things we can look at with rational functions as well. Now notice it says here, this shift though affects the domain. So now notice when we did this, the va moved over 1 place here. So now x can be any number except for -1. So what I would say here is the va is going to be x equals -1, and the ha is still going to be y equals 0. So some interesting things to look at here. Now let's look at the function y equals 1 over x squared next as we continue this video. And again, if we look at some values on tables and stuff, it's going to be similar, except with an x squared down here in the denominator. When we start putting values in for x here, and it depends on if we put positive or negative values in here, notice that as x gets larger and larger and larger, that y is going to get closer and closer to what number? 0. So if you think about this, 1/10, 1/100th, 1/1000th, 1/1,000,000th, 1 the national deficit. It's getting the fraction's getting smaller and smaller and smaller. Kind of reminds me of my paycheck sometimes. And then it gets closer to 0. All right, so here's what this graph looks at. And notice here when we go putting some x values in here, we've got the old plus or minus with that x squared in there. And here's what the graph looks like. So this graph, y equals 1 over x squared, increases on the interval, -infinity to 0. So on this side, notice it's going up. You got a positive slope along the x-axis, while from 0 to infinity, it decreases. So good increasing, decreasing, constant stuff here. It is discontinuous at that point, x equals 0. X cannot be 0 in this one. The y-axis is the va, and the x-axis is the ha. Now, this is an even function. So here's some more good exam review. We said that the last one, 1 over x, was odd because it had origin symmetry. This one is even, notice, because it is symmetric to the y-axis. Now, we can also make this thing dance, too. So notice here, if we take y equals 1 over x plus 2 squared minus 1, it says give the domain and range. This one is going to do a vertical shift down 1 and a horizontal shift, the direction you wouldn't expect, left 2. So notice that the va has dropped from the x-axis, or the ha, I'm sorry, not the va, the horizontal has dropped down 1, while the vertical asymptote has shifted over that way 2. And then the graph is very similar to what we've been looking at. So since they're functions, all of the translation things work. Now the horizontal shift affects the domain, notice, which is now all x values except for -2. X can be all numbers except -2 here, while the vertical shift affects the range, so the y values are what now? It says the range is now -1 to infinity here. Now also, you know what they should have done for the range, the y values here. Notice the y values, everything above this line. And they just wrap it up here. Vertical asymptote has the equation x equals -2, or the va, the ha, y equals -1. And we're going to come back in the next videos and talk more about asymptotes and rational functions. This is just kind of a warmer-upper here. Wait till we get to the good stuff in the next several videos. All right, I'm going to try to keep this video under a certain limit. So Professor Bob Young breaking this section up, signing off.